Hey everybody, welcome to my video. This is the first in my videos on data analysis and statistics. And what we're going to do today is we're going to talk about standard deviation, some meaning behind it, and how we can use a calculator to compute it. Regardless of what calculator you use, it's all pretty similar. Let's start off with a story. I was going to move to San Francisco a few years ago. I've been a New Yorker my whole life, lived here for about 35 years. And I thought that I was going to move to San Francisco because I was just sick of the cold winters in New York. I'd been to California before, been to LA, been to San Diego, but I'd never been to San Francisco, and I really just wanted to escape the cold weather. So I looked online and I did some research, saw how beautiful it looked out there, saw one of my favorite shows was filmed there from when I was a kid, and I was just ready to make a move. Now, one of the things I didn't like about New York City was the weather. So I went and I thought about how cold the winters were here, and I went to go figure out what is the average high temperature in New York. When you look at the weather for the day on your phone, on an app, on the news, what they tell you is what is the high temperature for the day. So if you look at your phone and it says today it's going to be 50 degrees, that means the highest temperature of the day will be 50. Well, what I wanted to know was what would be the average high temperature for the entire year for New York. So the first thing I went to go figure out is what is that average high temperature for New York? And when I looked online, what I saw was that the average high temperature was done by month. So when I looked at the average high temperatures for month, this was what I found. Why don't you take a guess and think, what is the average high temperature for the entire year in New York? I can see in March the average high temperature is 50. In May the average high temperature is 71. But what do you think it is for the entire year? Well, to find the average, what you have to do is sum all of the items and then divide by how many there are. Well, there's 12 months here, so you sum all these numbers, divide by 12, and your calculator should tell you something like this. This symbol here, X with this line on top, we call X bar. This is the symbol for average. And if I round this to the nearest degree, I can see that the average high temperature in New York City is about 62 degrees. Now, of course, I wanted to move to San Francisco because I thought it was going to be warmer. So I wanted to look and figure out what was the average high temperature in San Francisco. Well, when I calculate that, I had to figure out what is the monthly high temperature for San Francisco. So I got this, and I wanted to compute what is the average monthly high temperature for San Francisco. Well, again, to find the average, you sum all of the items. So I sum all of these numbers from 57 up to the final 57, and then I divide by 12. When I did that, I got an average temperature of 63.83 repeating, or if I round that up to the nearest, let's say, degree, I can see that the temperature is 64 degrees. Now, this threw a wrench in my plans of moving out west. Remember, I wanted to move to San Francisco because I thought it was warmer. But now when I'm comparing the temperatures, they're really not much different. San Francisco has a high temperature of 64. New York has a high temperature of 62. Does that mean that I'm really going to pick up my entire life, move across the country, leave my family, and only gain 2 degrees? So I had to look at a different number. So the next thing that I looked at when comparing these two cities was standard deviation. If I look here at the averages for them are very similar. We talked about how there were 62 for New York and 64 for San Francisco. But the number that was very different was standard deviation. This here is the symbol for standard deviation, and I can see that the standard deviation for New York City is 16, and the standard deviation for San Francisco is 4. Now think about what you know about these two cities. Think about what you know about New York City. Think about what you know about San Francisco. Think about the numbers here in the data for San Francisco, and think about the data for New York City. Based on that, what do you believe a standard deviation might mean? Well, what a standard deviation is how much the temperatures really, in this case, vary for this example. New York City has a very high standard deviation of 16 because if I look at the temperatures in New York City, they're very spread out. In the winters, it's very cold. 38-degree high temperature in January, 42 in February. When I look in the summer months, August, July, the daily high temperature is very high. It's 84 degrees. Because there's such a large variance in the temperatures, they go up and down, we have a very large standard deviation, meaning the items are more spread out. If I compare that to San Francisco year-round has pretty much the same average temperature. They're very close. But what San Francisco has that's different than New York is very consistent temperatures. Look at the temperatures in winter compared to summer in San Francisco. They're not very far off. In a winter month like February, the high temperature is 60, but yet in the summer, it only goes up to 67 or 68. If you're someone that really likes to wear shorts, maybe San Francisco isn't the city for you. You might not be someone that's dressed in shorts that often, but you also might not be wearing a winter or heavy coat. The temperatures are very consistent around 60. So if you like the seasons, you like winter and summer, and you like that variance, New York City is going to be better for you because it has a higher standard deviation. Let's copy down some of these definitions. We're going to be looking at data items and statistics in this unit. Data sets is a group of numbers, and what a statistic is, it's a numerical value that we can use to summarize and compare sets of data. We've already looked at two different statistics. We looked at average and standard deviation. Those are statistics. They summarize different sets of data so we can talk about them and compare them. When I wanted to move to San Francisco, it was important for me to look at different statistics to make sure that I was making the right decision. What the average is going to do is it's just going to be the number representing the typical value in the data set. That's why if you look at your average on the test, it's looking at how you did typically overall on the test, not on any one question, but what was the typical way that you performed. And standard deviation, what we just found out is it describes the typical difference between a data value and the mean. It tells you generally how spread out your data is. So if you think of San Francisco had a low standard deviation. That means that the data points were very close to the mean. There wasn't much variability. Where if I think of a high standard deviation, we could consider New York City to have a high standard deviation. That indicates that the data points are more spread out from the mean. When I think about an average, the average is what we call a measure of central tendencies. It tells us what's going on at the center of our data set. Where standard deviation is very different. It's not telling us what goes on at the center of our data set, it's telling us how spread out our data set is. Let's talk for a moment about how to calculate standard deviation. When I got these numbers here of a standard deviation of 16 and 4, where did these numbers come from? Well, there's many ways to calculate standard deviation. One way is you could do it by hand. If you were in a statistics course, you would absolutely do this by hand. We're not going to do that in this course, but I will summarize what it means. To find a standard deviation, what you would do is you'd first figure out what the mean is. Remember, the mean is this X bar. And what you would do is you take every data item in the set. In the case of temperature, you would take every temperature, subtract the mean. Take the next temperature, subtract the mean, and so on until you get to the last temperature and subtract the mean. What you then do with all of those numbers is you'd be finding the difference between the mean and a data item. You'd square them. You'd sum all of those differences once they were squared. You would divide by how many numbers they were, and then you take the square root. What we're going to do instead is we're going to use a calculator to do this. So every calculator is a little bit different. I'm going to show you how to do it using Delta Math, since that's the way most people are going to be using it. Let's do it for the New York City average monthly high temperatures and figure out how did we get a standard deviation of 16. So let's talk about how to compute standard deviation on Delta Math. What you want to do is when you're looking at your screen of where you have all your work due, what you want to do is open up the calculators over here. This opens up a calculator, and you'll see the drop-down menu here. I'm going to go to Statistics Calculator. When I do that, it opens another window where I have these lists here where I can input data items, and that's exactly what we're going to do. What I would do is take the data items of the temperature and list them one by one down the first column. If you want to use your keyboard, you can press the Tab button and that will go back and forth. And if you do so, eventually you should put in the data items. So the first month the temperature was 38, the second month the high temperature was 42, the third month 50, and so on. And you'd go all the way down to 12. You wouldn't put anything in the 13, 14, 15 because we're not looking at 13 months. Then very simply, you go to Calculate menu. From Calculate menu, you're going to keep one variable statistic on since we have one variable here, monthly high temperature, and you'd press Calculate. When you press Calculate, right here is all of the information that you would need. So the results that we got was this here. What this here tells us is all the information we know. We know that X bar is the average or the mean. That's where that high temperature of 62 degrees came from when we talked about the average high temperature for New York City. This is the sum of all the data items. If I add all the data items together, I would get this. Squaring them, right here is that standard deviation that we like. Here I rounded that number to 16, but it was originally about 15.7. This is the number of data items. We had 12, the minimum data item, the maximum. Right here I have the median, or the number in the middle, first quartile, third quartile. So all that information is there. Let's practice what we just learned about standard deviation by calculating standard deviation for two different data sets. What we're looking at here is two different data sets. Table A represents the average acceptance score to get into a SUNY school, something like my alma mater, UAlbany. And Table B represents the average acceptance score to get into a city college. My graduate's degree was from Hunter College, so there are two schools there that I attended. What I would like you to do is calculate the mean and standard deviation for both tables. When you do that, round your value to the nearest tenth. One thing to keep in mind is that you have to do this separately. First, find the mean and standard deviation for Table A. When you're finished, enter the items from Table B and find the mean and standard deviation for Table B. For Table A, SUNY schools, the average score was an 83.8 with a standard deviation of 5.5. For SUNY schools, or rather for city universities, it was a little bit different. The average there was an 85.9 with a standard deviation of 3.9. Which set of data here had a larger average? And more importantly, what do you think that means in the context of this data or of this problem? Well, clearly you can see that Table B has a larger mean. Table B has a mean of 85.9, where Table A has a mean of 83.8. What does that mean? Well, that means that typically it's going to be more difficult to get into a city school than it is to get into a state school based on this data, because this number is larger. Question 3 asks, which set of data has a larger standard deviation? And more importantly, what does that mean in the context of this problem? Well, here it's very obvious to see that Table A, the SUNY schools or the state schools, have a larger standard deviation than the schools in Table B. What that means is that the SUNY schools have a larger range or a larger variability when thinking of what types of scores are accepted. Or when I look at the city schools, their standard deviation is lower, meaning they have less variability or there's less variance in the types of scores and the types of students that are accepted based on GPA. Let's talk about thinking about standard deviation without calculating anything. In this problem, what I'd like you to do is, without the use of a graphing calculator, determine which one of these data sets has a larger standard deviation and explain how you determined your answer using complete sentences. To answer this question, we really want to go back and think about what is the definition of standard deviation. Remember that standard deviation describes the typical difference between a data value and the mean. A low standard deviation indicates that the data points will be very close to the mean, where a high standard deviation means that they'll be more spread out. In this problem here, we want to know which one has a larger standard deviation, or typically which data items are more spread out. If you look at data set A, all of these numbers are pretty close to 100. If you look at data set B, that's not true. They're all pretty spread out. It goes all the way from -5 to 30, 12 and 20. There's no number that they're very close to. So which one has the larger standard deviation? If you said data set B, you'd be correct. We could determine this by just looking and seeing that there was more variability in data set B, or they were more spread out from what the average might be than in data set A. Sure, data set A is larger. It's going to have a bigger average. But when I look at how close these data items to each other, they're much closer relative to one another than the ones in data set B are. Let's try one final question about standard deviation without a calculator. Here, suppose you have two sets of test scores, and we're not showing you the data sets, so just think about them in your head. They both have the same mean, but they have different standard deviations. We'll call the standard deviation for the first set standard deviation 1 and standard deviation 2, and you should know that the standard deviation of data set 2 is greater than that of data set 1. So which statement best describes the variability of these data sets? Well, right here is the key information that you need to know. It says the standard deviation for data set 2 is larger than data set 1. Well, what does that mean? By definition, larger standard deviation means more variability, more spread out. Think back to San Francisco and New York. San Francisco had a very large standard deviation because the temperatures were more spread out. So here, the one that we like is data set 2 has a greater variability. That's not true. The standard deviation for set 1 was smaller, meaning that they vary less. Choice C can't be true. The variability will not be the same unless it says that these two pieces here are equal, which they're not, and we can draw a conclusion, so that's not great. I hope you enjoyed this video. I hope you learned what a standard deviation is, how to find it with a calculator, and how to just compare data sets and decide which standard deviation was larger. Take care until next time.